Dear students, anhydrous aluminium chloride is covalent compound. Why? Before answering the question, I will take 2 minutes to explain some key points that will help us to explain the question answer. So the key points are conditions of ionic bond formation. Second point is condition for covalent bond formation. And third point is Fazan's rule. The students, we know that ionic bond means transformation of electron or electrons. On the other hand, covalent bond means sharing of electrons. Let's see the condition of ionic bond formation. One of the atoms must be metal and other be non-metal. That means ionic bond is possible between the atoms of metal and non-metal. Second point, the metal atom must have the low ionization energy. Third point is high lattice energy. Fourth point is the non-metal atom should have a high electron affinity. The electronegativity difference must be greater than 2. Size of cation relatively must be greater than the size of anion. Those are the key conditions of ionic bond formation. Second point, conditions for covalent bond formation. Atoms will be usually non-metals. Electronegativity difference must be less than 1.8 and the size of anion relatively must be greater than the size of cation for forming covalent bond. Now, third point, Fazan's rule. Fazan's rule tells us some necessary condition for forming ionic and covalent bond. For ionic bond, low positive charge, that means cationic charge must be low. Large cation, that means size of cation must be large, and a small anion. Secondly, some conditions for covalent bond formation: high positive charge, that means cationic charge must be high, and a small cation and large anion. So the students, those are the preconditions for ionic bond formation and covalent bond formation. Now, you have to justify the bonding nature of sodium chloride molecule and ammonia molecule. After that, I will give the final question answer. Anhydrous aluminium chloride is covalent compound. Students, now you can explain the bonding nature of anhydrous aluminium chloride by the help of different parameters that I have already discussed. Firstly, it is clear from here that aluminium is metal and chlorine is non-metal, so there must be an ionic bond, but the reality is completely different. First of all, we have to calculate the electronegativity difference between the atoms of aluminium and chlorine. The electronegativity of chlorine is 3.00 and aluminium is 1.5. So their electronegativity difference is 1.5, which is less than 1.8. So there must be a covalent bond. Secondly, aluminium has very high ionization energy. Now you can calculate the ionization energy of aluminium. First ionization energy is 578 kilojoule per mole. Second ionization energy is 1882 kilojoule per mole. And third ionization energy is 2740 kilojoule per mole. So the total ionization energy of aluminium is very high. And for chlorine, it is not easy to withdraw 3 electrons from aluminium because chlorine is not enough electronegative. So aluminium shares its 3 electrons with 3 chlorine atoms, so covalent bond is formed. Secondly, you can write your answer that the aluminium ion has high charge density, that means Al3+, while the chlorine ion is relatively polarizable. So Al3+ ion is able to pull the electron cloud of chloride to such a great extent that there is orbital overlap between aluminium and chlorine atoms. So the bond is covalent. Now, You can explain the bonding nature of aluminum chloride with different parameters. Now finally, we have to see the Lewis dot diagram of aluminum chloride. Here, aluminum shares its 3 electrons with 3 chlorine atoms. Cl, 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 Cl. 3 chlorine atoms and single orbital remain vacant. So, the bonding nature of anhydrous aluminium chloride is covalent. Please subscribe my channel and get all chemistry related question answer in details. That's all for today. Bye.